Hello and welcome. I'm Nick Gibson and I'm joined by Paul Bullock from Wireless Logic to talk about interconnectivity. Paul, welcome.
Thanks, Nick. Good to be here.
Recent reports show that less than 40% of companies currently use interconnected tools to measure, manage and control data and processes that are key to their business. Why is this and what are these companies missing out on?
Well, first of all, I think the other 60% are currently looking at it. 5 or 10 years ago, there were legitimate questions about the ROI from IoT investments. I think those questions are across the board being answered positively now. We routinely deal with very large enterprise that are using IoT and that family of interconnected things to drive digital transformation, to have a cradle to grave deep understanding of the behavior and performance and all that stuff about their products, and also to reduce their carbon impact. You know, the thing about IoT is that a lot of it is moving electrons rather than moving carbon. And so this becomes an important part of corporate responsibility, and happily it saves and makes money.
So I was going to ask about the IoT shortly, but as a again, just to provide some context, if I may ask, we live in a data-driven world that relies on telecoms and its ability to connect disparate platforms and devices. From your perspective, what's the current state of telecoms interconnectivity? Is it getting better? Is there enough of it?
It is getting better. In my mind, I separate wired and wireline connectivity, and wired and wireless. And wireless connectivity, from a networking point of view, has been a barren wasteland of innovation for many, many, many years, because the mobile operators were set up on a national basis. They were granted oligopolies through their purchase of spectrum and their payment to government of those fees. And that inhibited innovation dramatically. Every few years you get an additional G, and the phones are obviously amazing. But networking technology has lagged behind compared to the internet. For instance, a typical example is when you go on holiday to Melbourne with your Vodafone UK phone, every single packet that you look at comes all the way back through the UK. This is obviously crazy, but it's a symptom of the problem. What we have happening now is the advent of mobile core software that's dramatically, like orders of magnitude, less expensive than it was even a decade ago. And you have on-SIM technology that means we can assign different networks to a SIM. And collectively, that means you can build a layer 3, a layer 3 type network across all of the mobile operators in the world, which is what Wireless Logic does. So we see a dramatic opportunity in cellular networking, where we're probably in the 56K modem phase of cellular networking now, and we will get to the fiber to the home phase soon.
Well, let's hope so, because it seems like everything, well, most things, especially for any kind of collaborative working and remote working, etc., even sort of connectivity at home, everything has sort of moved to the wireless spectrum. And yes, there's an awful lot being promised with 5G in Britain. You know, 5G doesn't cover the whole of the country by any means. So is it still a matter of a sort of conga line, concertina, you know, where some things move forward and then it takes a while for everything to catch up with it, and there's something of a gap sometimes in the middle, isn't there?
There is, and in any network you can only go as fast as the slowest bit. So if I understand your comment or question, the slowest bit in achieving this is sometimes security, sometimes it's device identity. Sometimes it's interoperability. Sometimes it's commercial models. But the cellular wireless industry does lurch forward in tiny steps and the occasional leap in addressing each of those areas. Device identity, interoperability, and the cost models. I mean, happily for the population, everything just gets cheaper. So that's good. And that drives different networking services innovations because people can't make money out of selling megs the way they used to. And that in turn, hopefully, composes a virtuous circle of people resolving the other roadblocks.
You've highlighted an issue in terms of connectivity and interconnectivity with more and more sort of connection points, especially throughout business now, with so many different platforms and systems and software programs, and a workforce that is all over the place. This rather increases risk and vulnerabilities around the connections and also the data that those connections carry. What's your view at the moment in terms of sort of data security?
It's fundamental, of course, to everything. Brand value, human safety sometimes. And in wireless, what we are an advocate of and see happening is bonding device identity to connectivity. And that means things like putting encryption certificates into the SIM. A lot of people aren't aware your SIM is identical to your bank card, literally identical, made in the same factories. But your bank card is performing a lot more security functions than your SIM is. There's no reason SIMs can't take on some of that security function to lend a device identity, to lend it encrypted keys so that it can set up transport layer security or VPNs, so that transactions that are coming out of that device, say like a smart meter, or even a point of sale terminal for that matter, can be signed with those keys for authentication and written into an immutable digital ledger that enhances the overall commercial and transactional security of the thing that you use a SIM to connect.
You mentioned the Internet of Things. Obviously, IoT relies upon connectivity, and as you just mentioned, with smart meters, etc., increasingly with wireless connectivity. It's an increasing tool of business and industry, but it's not an easy path to follow. From your point of view, what kind of challenges do businesses face with their IoT rollouts in light of things like the PSTN switch off, phasing out of 2G and 3G networks, and ongoing security concerns?
Yeah, well, I mean, we spend many hours of our day solving those problems and thinking about how to solve those problems. So, I mean, there's classes of these problems, but sometimes they're use case specific. So, in cases like your retirement of 2 and 3G, enterprises looking for multinational deployments have to be really aware of markets they might want to enter. What are the prevailing radio conditions there? Can I even get something like a low-powered wide area network connection? Lots of places you can't. So then you turn to your device. Which module am I going to select? Which module is going to give me the radio that I need with the right power budget that can allow me to create a product that's going to last the 6 years I want it to last without having to weld a car battery to it to power it? And all these conditions and options form a decision matrix that we spend time taking clients through that decision matrix until they get to the right mix of, I better build it so that I can release my product in Burkina Faso, because that might be something that happens. And maybe I really only need this thing to last 4 years. And maybe and ultimately you get to the right answer from a connectivity and device design point of view. From realizing commercial benefit point of view, there's a significant time to value piece. So enterprise has to organize the rollouts in a highly reliable way, so they know how fast the data that they need and the operational efficiencies that they want are going to be realized. A lot of failures in IoT projects come just because they take too long. And by the time it's kind of 63% done, everybody's a bit bored with it, and they probably spent more money on it than they intended. And those are often a function of poor planning.
I was going to ask there about the technologies and the applications around them are accelerating at quite a pace. I mean, they're all built upon the, standing on the shoulders of giants kind of thing. So where these things take a long time and a lot of capital investment, is there a danger that in some respects, some of these approaches and some of the technologies and applications might be leapfrogged by something else?
Certainly. I mean, we're living there's what you're touching on there is on-device convergence. So 10 years ago, I had to DIY my tracking device that went into a car, and it was made by a kid in the basement. 10 years from now, that'll be just a solid state component I can buy, probably. In the same way that when you and I built our first personal computers, there was about 150 parts, and you had to really think about how they were put together. And now the sound card is on the motherboard, and building a computer is 4 pieces, and they're all color coded. It's quite boring. That's the direction IoT devices are headed. Yeah,
you talk about the past. I do remember when memory was £100 a meg.
Yep. And we all remember when a gig of mobile data required a remortgaging of the house.
So from your point of view, what does the future of connected technology look like? And how can things like eSIM technology help organizations? I think you touched on that earlier.
Yeah. eSIM, iSIM even. And that family of technologies is in the basket of on-device convergence. And so eSIM and the ability to manipulate network identities on a SIM means I can have one SIM to rule the world, means I have a standardized approach to my cellular network, means I don't have separate product SKUs, which is a crazy expense if you're making a lot of something. And it means you can have a harmonized approach to operating your business at global scale when cellular connectivity is an important piece of it.
So will these things basically come from the network providers? Will they come from specialists who manufacture these things, or will they be built into devices in future?
So the mobile network operators, as a rule, don't like this stuff because they prefer to have a SIM be handcuffs. And obviously, nobody else wants that. So this innovation is being driven outside of the mobile operators and is being forced upon them by regulators, thankfully. So famously, I think last month, Apple announced that in America, in America at least, they are abandoning physical SIMs. So all this innovation is coming around the mobile operators and in spite of them. So we'll still see that happening. And yeah, I think does that answer your question?
Well, yeah, it does actually, and it leads me on to a question about regulation. I mean, there's always a push and pull. Does regulation drive the market, or does it trail behind and as something of a hindrance? But clearly, from the example you've given there, in this instance, regulation is something which will actually be enabling and empowering to a
100%.
wide range of industry and business, etc. So clearly, that on this occasion, you welcome such regulation.
Absolutely, and I put it in the family of antitrust legislation. Just because one big block of shareholders are sitting on an important technical capability in society doesn't mean they should be allowed to prevent it from changing for the better, even when those changes are going to probably negatively affect the business model that brought that technology into being in the first place. And only legislation will force them to do that.
Thank you. In terms of wireless and the growth and the increasing importance of wireless, when it comes down to the Internet of Things, the metaverse, things like this, is there going to be enough bandwidth? Because a lot of people are worried that there won't be enough power and bandwidth to basically deliver on the promise of all these things. Do you think there'll be enough bandwidth available for everyone?
I do. I've got a fairly dim view of the metaverse, but putting that aside, the thing about bandwidth is that you don't need planning permission to put up more of it. You need more boxes, and you need faster algorithms, and you need faster modems and decoders and all that stuff. There's probably some physical limits, but we're quite a ways away from hitting those.
Well, with the advent of all kinds of supercomputing power and quantum computing, there is a race to that kind of speed and grandiose power capability. So all being well, I take on board what you say about the metaverse. It's something of an empty warehouse at the moment. It'll probably remain that way for some time, especially one person's grandiose vision, until it can actually deliver what people want. And no one's going to be walking around with these things. Do you know, I first put on a pair of VR goggles in 1985, and it's taken this long.
And last pair I put on still made me feel a bit nauseous. So, and yeah, I think it's a spasm of weirdness from a billionaire, but whatever. Maybe he's right. Maybe I'm wrong. What do I know?
If only we had such billions to indulge ourselves as well. Paul, unfortunately, we've come to the end of our allotted time. I do thank you for your time. I appreciate it. You've actually raised a number of points and issues through your own practical experience that I personally wasn't aware of. And I know that people watching this and reading subsequent features will take a lot away from what it is that you've said. So thank you so much. Thank you for your time and your insight. And I personally wish you and your organization every success in your future endeavors.
Very good, Nick. I'm grateful for your time. Thank you.